So now let's take a look at probability distribution. It says a probability distribution of a random variable is a table, equation, or graph that links each possible value of x with its probability of occurring. These probabilities are determined theoretically or by observation. So no matter what, the probabilities are always between 0 and 1. So like 1 represents 100% of something happening, 0 represents nothing, it never happening. And so the way you will see this using symbols is that 0 is less than or equal to the probability of x occurring, which is less than or equal to 1. So you flip a coin, typically we think of it being 50%. That would be 0.5 between 0 and 1. That's an example there. The sum of all probabilities must equal 1. That means if it's discrete, you'd be using the sum, and it'll equal 1. No, all probabilities added together should always equal 1. So for example, the probability of getting a heads is 50%, the probability of getting tails is 50%. You add those two 50% up and you get 100% or 1. So here's an example. It says, moviegoers were asked to rate a movie. The possible ratings were 1 for poor, 2 for average, or 3 for good. Use a frequency distribution shown here in this table to construct and graph a probability distribution for the random variable x. So what I'm going to do here is I'm just going to add on to my table, and we're going to find the probability of each occurring. So I'll write in here probability. So this chart right here is going to refer to the total. How many total did we have? Well, I'm going to go use a calculator, and I'm going to refresh this to get that off the screen. So if I want to determine how many total there were, let's see, there's 12 plus 14, which is 26, plus 37 more is 63. So we have 63 here. Let me get that off of there. Okay, 63 total people observed a movie or rated a movie. So the probability of the first occurring is 12 over 63, which I will get that as a decimal in this moment. The probability of the second occurring would be 14 of 63. So notice this is not cumulative this time. We're not adding these up. And the probability of the third occurring is 37 over 63. So we can go to the calculator and find each of these values. 12 divided by 63 is 19%. And so these also should always add up to 1 when you're all said and done. Now, if it doesn't, it's probably a rounding error. The second is 14, which is 22%. And the last, 37 of 63 is 58.7. Now, if you add these up, you'll see that they don't actually add up to be 100. That's because there we have a rounding error. So truthfully, I should have just added an extra 0 or a decimal place. That would have helped us get a better set of values. That right there will not equal 1. But what if we added up these numbers, we would get 63 of 63, which needs to equal 100% for the total. Okay, so these I just did not round. I should have rounded to the nearest hundredth. So let's just change a couple of these really quickly so you can kind of see how this works. 58.73%. Let me erase these two. 14 divided by 63 is 22.2. Oh, there was part of my problem before. As this was always 22.2, now it's 22.22%. And then let's also see the 12, what that was. 12. 19.05. And now if you added those up, you would get your 100%. These values would add up. So that would be our probability. And so a probability distribution might look something like this, where you graph the rating, and then you show the probability. So you wouldn't put the frequency over here, you'd put the probability. We know this is like basically let's call it 19.1%. This right here is 22.2%, and this would be 58.7%. That's the idea there. Okay, for this DOL, I'll let you take a look at the problem and the frequency table. And now I'll let you look at the different probability distributions and see which one's correct. Pause the video if you need to.